All right, here we are for the second half of the pre-calc review. All right, this first 13, 14, 15 are going to be graphs. This first graph has a lot going on. The minus pi over 2 shifts it to the right pi over 2. The minus 1 shifts it down 1. The 2 multiplier in front doubles the amplitude, makes it stretch to a height of, or a change of 4 instead of a change of 2. But all this stuff is going on. Remember that the sine graph, oops, sorry about that. The sine graph will starts at 0, 0, okay? The normal sine graph, okay? So sine starts at 0, 0. Now this one is going to get shifted to the right pi over 2. So actually that 0, 0 turns into 0, negative 1. So a couple of things happen on this one. At 0 itself, 0 minus pi over 2 is negative pi over 2, and the sine of negative pi over 2 is negative 1, and 2 times negative 1 is negative 2, and negative 2 minus 1 is negative 3. So this one actually starts at 0, negative 3, okay? It's on a, and then it's going to start to climb up. At pi over 2, so pi over 2 minus pi over 2 is 0. Sine of 0 is 1. 2 times 1 is... sine of 0 is 0. 2 times 0 is 0, and 0 minus 1 is negative 1. So at pi over 2, it's at negative 1. Pi over 2, it's at negative 1. That's part of the down 1 shift there. At pi itself, pi minus pi over 2 is pi over 2. The sine of pi over 2 is positive 1, and 2 times 1 is 2, and 2 minus 1 is positive 1. So it reaches its peak at pi, Then at 3 pi over 2, it starts to go down again. 3 pi over 2 minus pi over 2 is pi. Sine of pi is 0. 2 times 0 is 0. Minus 1 is negative 1, so it starts to go down again. And then at 2 pi, it's going to be back down at negative 3. 2 pi minus pi over 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. So these are some ordered pairs. Let's take a look at what's going on here with the graph then, okay? So I'm going to put the graph right there, put positive 1 up there, negative 1, negative 2, negative 3. So at 0, it's already at negative 3. At pi over 2, excuse me, at pi over 2, it's at negative 1. At pi, it's at positive 1. At 3 pi over 2, it's back down to negative 1. At 2 pi, it's down to negative 3. So it's kind of going, this is one cycle, one period of it. Okay, whoops, kind of missed that dot there. So if we extend this out to the right a little bit more with our pi over 2s, this would be 5 pi over 2. This would be 3 pi. So at 5 pi over 2, it's going to be back at negative 1. At 3 pi, it's going to be up to positive 1. At 7 pi over 2, it's going to be back down to negative 1. And then at 2 pi, it's going to be down here back at negative 3. So we swipe that up, swipe that down. Okay, there it is. All right, 14. 14 is a secant graph. Now, a secant graph is some U-shapes that are on the humps of the cosine graph. So this is the graph we're going to do first, cosine 2x. And then we're gonna put the asymptotes in and make the U-shapes off the humps of the cosine graph. So a couple things that are going on in this one. At cosine 2x, at 0, cosine starts at 0, 1. 2 times 0 is 0. So this one is going to start at 0, 1. And then at pi over 2, 2 times pi over 2 is pi. Cosine of pi is 0. No, it's cosine pi negative 1. Cosine pi is negative 1. So this is going to be down at negative 1 at pi over 2. At right in between here is pi over 4, and at pi over 4, it's going to be at 0. All right, pi over 4, it's going to be at 0. And at pi, all right, at pi, 2 pi times 2 would be 2 pi. Cosine of 2 pi is 1. So it's going to be back up to 1. But in between here, at 3 pi over 4, it's going to be at 0. So let's take a look at what this looks like. Making the graph there, there. So we're only going up to 1 and down to -1. But then we're going to get some U-shapes here. So at pi over 2, it's at -1. Oh, sorry, at 0, it's at +1. Now here's pi over 4. That's where it's at 0, at pi over 4. And then at, right here's pi. At pi, it's back up at +1. But in between, it went through 0 again, so 3 pi over 4. So it's going to kind of curve like this, and then back up. And maybe this statement there, that's be 3 pi over 2. It's going to be back down at -1, but in between here, it's going to go through 0. All right, and it's going to go back at 2 pi. It's going to be up at +1, but it's going to go through 0 at that 1/4 thing. All right, so here's how this looks. I'm going to make an asymptote there, asymptote there. Asymptote's where it goes through 0. And then the actual secant graph is going to be these things. It's going to be these U-shapes here, U-shape here, U-shape here. And there's going to be another U-shape here, and there's even one right here. All right, there's your secant graph. The red one is the secant graph. All right, last one, last graph one, cotangent. And these are a bunch of S shapes. The 4 is going to make it elongated a little bit. The -3 shifts everything down 3. All right, so here's how the S shapes are going to look. I've already done some things and found where the asymptotes are undefined, where cotangent is undefined at 0 and at pi. And then we'll get some S shapes drawn in here. So draw this in. All right, I'm going to draw this in. So here's +1. Here's -3. Okay, and it's actually going to go down to -7. But so if I call this pi, this 2 pi, and 0. So these are where it's undefined. It's undefined here, it's undefined here, and it's undefined at 2 pi. Now, the -3, the shifting down 3, at pi over 2, it's already down at -3. That's kind of the middle of this. But at pi over 4, in between there, it's actually 1. So in between here and here, it's actually at +1. Now, in between here, it's going to be way down at this -7. So -7 is way down here. So this is a really skinny, oops, it's going to kind of go through that dot and kind of curve through that dot and keep going down. So same thing is going to happen over here. It's going to be right there at -3. Here it's going to be at +1. Here it's going to be way down at -7. So it's going to kind of come up like that. All right, it's a mess, but that's what the cotangent graph there looks like. All right, moving on. Numbers 16 through 19. Got to do some work on the on this. So number 16 says cosine pi over 3. So number 16, when it asks for this, it's saying, what's going on with the x value at pi over 3? Well, pi over 3 is right here. The x value is 1/2. So that's the x value right there. That's it. That's all I got to do. For number 17, it's asking for the cotangent, 3 pi over 4. So it's asking to do this at that 3 pi over 4. So 3 pi over 4 is right here. All right. So it's these two items. Well, those two items are the same, except one's negative, one's positive. So if I divided those, it says x divided by y, I would get -1. I'd get -1. All right. So cotangent at 3 pi over 4 is -1. Number 18. Number 18 is asking for the arc sine of radical 2 over 2. Well, the arc sine, you're looking for the sine is y. You're looking around the unit circle where you get this as a y value, square root of 2 over 2. So if we look, oh, right there it is. Square root of 2 over 2 is the y value right there. So arc sine of square root of 2 over 2 is pi over 4. Pi over 4. And number 19. 19 is like a double whammy one. It's the tan of the arctan. Well, the tan and the arctan just cancel each other out. the tan of the arctan of 2 is just 2, because tan and arctan just cancel each other out. And that's all you got to do for 19. Numbers 20, grab a calculator. 20, you got to make sure you're in degree mode. If you don't know how to turn your calculator to degree or radian mode, just ask. I'll show you. So you want to find the sine of 34 degrees. Just hit the sine button, type in 34, and hit enter in degree mode, and you get 0.5592. For 21, you got to go back to radian mode, and you just hit the calculator. Well, this one's cosecant of 4.7. That means you have to do the inverse of sine. So you got to do 1 over, or sorry, not the inverse, the reciprocal. 1 over the sine of 4.7. All right, that's how you type that into your calculator, since cosecant is the reciprocal of sine, and you get negative 1.0001, so pretty close to negative 1. All right, that's 21. 22. 22, you're doing the inverse tangent of 23.4. And you can keep this in radian or degree mode. I kept mine in radian mode. And you just have to hit the second button on the if you're using a TI-84, and then hit the tan button, and then type in that 23.4, and it'll tell you the angle. If it's in radian mode, it'll tell you the answer in radians, 1.528 radians. All right, that is 22. Now, 23 and 24, you got to do a little bit of rewriting. All right, 23 says tan squared theta times cosine squared theta plus cotangent squared theta sine squared theta equals 1. So they want you to do a bunch of rewriting. Now, tan is sine over cosine. So we're going to rewrite tan as sine squared theta over cosine squared theta. And we're going to keep the cosine squared theta there. And then cotangent is cosine over sine. So cosine squared theta over sine squared theta times sine squared theta equals 1. Well, we get some canceling here. In this first group, the cosine squared thetas cancel out. So all we're left with is sine squared theta. In the second group, the sine squared thetas cancel out. So we're left with cosine squared theta. Well, sine squared theta plus cosine squared theta is equal to 1. So 1 equals 1. So we've turned it into the Pythagorean identity, if you will. All right, question 24. Question 24. Got to do some rewriting in this one. So this one says tangent squared theta times cosecant theta over secant squared theta equals sine theta. So we're going to rewrite everything in terms of sine and cosine and see what we can get to cancel here. Tangent, remember, is sine over cosine. Since that's tangent squared, we're going to go sine squared theta over cosine squared theta. Cosecant, cosecant is 1 over sine. So 1 over sine theta. Now, secant squared theta at the bottom is 1 over cosine squared theta. All right, let's see what happens over here on the right side. Well, on the top of on the left side. On the top of the left side, 1 sine cancels out with 1 sine there. So I'm left with sine theta over cosine squared theta on top. But this, I can multiply by the reciprocal. So I'm going to multiply by cosine squared theta over 1. Oh, look, I can cancel out my cosine squared thetas. All of these cancel with all of these. Hey, and I'm left with sine theta equals sine theta. And I'm done with 24. All right. Number 25. We do have a statement in this chapter that sine of negative theta is equal to the negative of the sine of theta. So if they tell us that sine theta is equal to 1/2, then sine of negative theta would just be negative 1/2. Done. 25. 26 and 27, we want to go back to the unit circle for 26 and 27. For 26, it's telling us that cosine theta is equal to negative 1/2. So we're looking, cosine, remember, is y, or sorry, your x's. So I'm looking for any x values. I'm starting on my unit circle, working my any x values that are negative 1/2. So x values, negative 1/2. Right here's one, okay? So 2 pi over 3. So theta is equal to 2 pi over 3. And looking for another one where we get negative 1/2 right here, 4 pi over 3. All right, those are the two thetas that would have x values of -1/2 for the cosine. 27, they say secant theta is equal to 2 radical 3 over 3. Well, remember, secant is the inverse of cosine. So if I flip this upside down, I have the cosine. So cosine theta is equal to 3 over 2 radical 3. So I have to simplify this a little bit. I got to multiply by a radical 3 and a radical 3. So I'm going to have 3 radical 3 over 2 times 3. So it's going to be 3 radical 3 over 6. But the 3 and the 6 would simplify to 1/2. So it's square root of 3 over 2. So I'm looking at my x's again, because that's what secant is. It's the inverse of cosine, or it's the reciprocal of cosine. So I'm looking at my x values for square root of 3 over 2. Right there. Boom. Hit one right away. Pi over 6. And square root of 3 over 2 again. It's right here. 11 pi over 6. All right. That's number 27. And number 28, a little bit of tangent problem here. We know this is 37 degrees. This is x, this is 15, so we're going to say tan 37, got a right angle here, is equal to opposite over adjacent. So I'm going to cross multiply. 15 is equal to x times tan 37. So I'm going to divide both sides by tan 37. I got to type that into my calculator. Make sure I'm in degree mode. Whoa, lost it there. Make sure I'm in degree mode again. And when I type in 15 divided by tan 37, out will come my answer of, I had this earlier, sorry for the delay. 15 divided by tan 37 is 19.91 feet away from the wall. So I like right triangle trig. It's not bad at all. All right. Hopefully you get some good use out of this. Good luck on your test. All right. Good luck on your test.